Okay, so have you ever like plugged something in and thought, is this AC or is this DC? I feel like most people probably don't think about it very much.
Right.
But it's kind of one of those things you kind of should know, right?
Yeah.
So that's what we're going to be talking about today.
Okay.
We're taking a deep dive into AC/DC electricity.
It's really quite fascinating how these two forms of electricity are just kind of like woven into every aspect of our modern lives.
Yeah.
Even though we don't really think about it very often.
Right, exactly.
Yeah.
So to help guide us today, we have, we're going to be looking at a couple of things.
Okay.
There's this really cool interactive tool. It's from Open Educational Resources / Open Source Physics at Singapore. And they've got all these appliances categorized by whether they use AC or DC power.
Okay.
I thought that was a really cool visual aid for like understanding these concepts.
Yeah.
And then also we have an article called AC or DC Appliance from the same folks. So I think these are going to be really helpful resources for us.
Yeah, absolutely. A fantastic foundation for our deep dive.
Okay.
Yeah.
So before we jump into all that,
Sure.
let's start with just the basics.
Okay.
What exactly, the difference between AC and DC?
Yeah, sure.
Like, what is it?
At its core, it really is about the flow of the electrons. So in AC, or alternating current, those electrons are constantly changing direction.
Right.
They oscillate back and forth like a wave.
Right.
And then DC, or direct current, it's more like a steady stream.
Gotcha.
It's just going in one direction like a river.
Okay.
Yeah.
So that makes sense. So why do some appliances specifically need AC power to function?
Oh, that's a great question.
What is it about AC that they need?
It really comes down to the design and the mechanics of the appliance itself.
Okay.
A lot of appliances use motors, right?
Yeah.
To generate movement.
Right, like a fan.
Exactly,
Yeah.
like a ceiling fan.
Yeah.
Those motors need a rotating magnetic field to spin. And that's where AC current is really, really good.
Okay.
The alternating nature of that current creates a fluctuating magnetic field
Right.
that basically pushes and pulls on the motor,
Okay.
causing it to rotate.
Oh,
Yeah.
so it's the constant switching of the direction that creates that rotation.
Exactly.
Gotcha.
Yeah.
Now, we're looking at this interactive tool.
Yes.
And it shows that things like smartphones are GC powered, which I guess makes sense because of batteries. But
Yeah.
what about DC makes it so good for like those tiny electronics in your phone?
Oh, that's an excellent point.
You know, like those little chips.
Absolutely.
Why DC?
Well, the batteries being a DC source is certainly part of it, but it really goes deeper than that.
Okay.
DC power provides this really stable and consistent flow of electrons, which is super important for the complex circuitry
Okay.
in modern electronics.
Right. It's all very precise.
Exactly.
Right.
Those components, they just operate best with a constant voltage and current. And that's something that DC is really good at.
Yeah.
Plus, DC circuits tend to be less susceptible to energy loss
Okay.
over the short distances you find within a device like a smartphone.
Oh, I see.
Yeah.
So it's more about precision
Yeah,
and stability.
exactly. It's all about choosing the right type of power for the job.
Right. Okay.
Yeah.
Now, thinking about the history of electricity,
Sure.
I know there was this huge rivalry between Thomas Edison and Nikola Tesla, right?
Yeah, the war of currents.
Yeah, the war of currents.
Yeah.
And Edison was super into DC power, right?
Indeed, he was.
He thought it was just like way better.
He was a staunch advocate for DC,
Yeah.
believed it was the superior and safer option.
Okay.
Yep.
But then Tesla was all about AC power.
Yeah, Tesla was on the AC side,
Yeah.
recognizing its advantages, especially for large-scale power distribution.
Right. He saw the future.
So if Edison was so convinced about DC, what made AC ultimately, like, win out?
Yeah, what had...
Like, what were the factors?
Well, it really boils down to AC's ability to be transformed in terms of voltage.
Okay.
It could be stepped up or down using transformers. And that's really crucial for efficient long-distance transmission of power.
So it's all about, like, getting that power from where it's made out to, like, our houses without losing it along the way.
Yeah, you don't want to lose it all in the lines as heat and stuff.
So those big power lines that we see, that's AC running through those.
Absolutely.
Because it can travel so far.
Exactly.
Yeah.
Those power lines, they're carrying high voltage AC.
Right.
Because it can go long distances without losing a ton of energy is heat.
Okay.
Like DC would at a lower voltage.
Okay.
And then you get closer to neighborhoods, and transformers take that high voltage back down to safe levels.
Oh, I see. For us to use in our houses.
So it's like electricity has its own highway system.
Yeah, kind of.
You know, it's going really fast on the high voltage,
It's zipping long.
long distance.
Yeah, super highway.
And then it's got to slow down to go into the neighborhoods.
Exactly.
So that makes a lot of sense.
Yeah.
But you know how we were saying that DC is good for like batteries and stuff?
Right.
Could we see DC making a comeback?
You're spot on with that.
Really?
Oh, yeah. While AC still dominates our power grids,
Okay.
DC is definitely having a bit of a resurgence,
Uh-huh.
especially in modern electronics.
Oh, okay.
And we're even starting to see it more in power distribution systems.
So is it kind of like now AC is for that long distance travel,
Mm-hmm.
and then DC is for like powering our devices?
Precisely.
Okay.
And maybe even our homes in the future.
Wow.
Yeah, think about solar panels.
Mm.
Those generate DC power.
Right.
And solar's getting more and more popular.
Yeah, it is.
So we're seeing a rise in systems that use DC, at least for part of their distribution.
So instead of immediately converting it
Yeah.
from DC to AC,
Right.
so it can go into the grid,
Mm-hmm.
we can use DC more directly.
Exactly.
Right.
And the advancements in power electronics
Okay.
are making it easier and more efficient to convert between AC and DC.
Okay.
So we might even see a future where homes have these hybrid systems,
Oh,
you know,
interesting.
using both,
Okay.
depending on what you need to power.
This is really making me think about electricity differently.
Mm-hmm.
You know,
It's exciting stuff.
we've gone from electrons to the war of currents,
Yeah.
and now we're talking about like a DC comeback.
Yeah.
It's really cool.
It really shows you how interconnected everything is,
Yeah.
and how even something like plugging in a device, it's not as simple as it seems.
Right. It's got this whole backstory.
Absolutely.
So with all of this in mind,
Mm-hmm.
what does this mean for us?
Yeah.
Like everyday people.
Yeah.
What's the takeaway?
Who use electricity. It feels like we just barely scratched the surface here.
Yeah.
But I already understand so much more
Mm-hmm.
about how our electrical systems work.
Yeah, and I think the biggest takeaway for me is that AC and DC aren't competing.
Mm.
It's not like one against the other.
Right.
They each have their own strengths
Yeah.
and ideal applications.
So it's more like they work together,
Precise.
not against each other.
They complement each other.
Right. Okay.
Yeah.
And, with all this new technology, like renewable energy
Yeah.
and super efficient electronics,
Mm-hmm.
could we see DC becoming the main thing again?
Yeah, that's a really interesting question. Will we shift back towards DC being dominant, or
Mhm.
will they continue to kind of coexist,
Right.
each playing their own role
Right.
in our electrical world?
That's such a cool thought.
Yeah, it is fascinating.
It makes you realize that
Mhm.
even electricity,
Is constantly evolving.
it's not static.
So who knows what the future holds?
Exactly. There's so much more to learn and uncover.
Yeah, and that's what makes it all so interesting, right?
Absolutely.
So to our listener out there,
Mm-hmm.
hopefully this has made you think a bit more
Yeah,
about AC and DC power.
that's the goal.
You know how it all works,
Mm-hmm.
and we really encourage you to keep learning
Yeah, keep asking questions.
about the amazing technology that powers our world.
It's all around us.
So until next time.
Yeah, see you then.